All right, let's look at another basic Maclaurin series for natural log of 1 plus x. All right, so this one, we're going to use an integration to find it. All right, so we have no clue what to do from here. So we have, I'm going to let f of x equals natural log of 1 plus x. All right, then we look at the derivative, f prime of x, which is going to be 1 over 1 plus x. All right, and we've done this guy before, since we can simply rewrite it as 1 over 1 minus negative x. All right, so we can use the geometric series to conclude that this is going to be a summation. N goes from 0 to infinity. Negative x to the nth power. All right, and we can probably separate the negative 1 here, so it's a summation. N goes from 0 to infinity, and so you have a negative 1 to the nth power. Then we have x to the n. Right, but remember that this is a Maclaurin series for the derivative. So in order to get the Maclaurin series for the original function, we can take the antiderivative. So f of x is going to be antiderivative of summation n goes from 0 to infinity. So we have a negative 1 to the nth power and times x to the nth power. With respect to x. Right? And we can take the antiderivative term by term. So we're going to get this. So we can leave the summation outside. So n goes from 0 to infinity. Right? And a negative 1 to the n is just a constant. So it's going to stay there unchanged. Right? Then you have to take the antiderivative x to the n. So using a power rule, so add 1 to the power, so n plus 1 power, then you would have to divide by n plus 1, right? Since this is the indefinite integral, you would have to consider plus some constant c, right? And let's figure out c, right? So we know that from the original function, f of 0, right, because it's centered at 0 since it's a Maclaurin series, you get the natural log of 1 plus 0, so natural log of 1, which is actually 0. All right, so if you plug in 0 for here, so here we plug in f of 0. All right, so you can see that since we're plugging in 0 here, all the terms is going to be all 0. So what's left is going to be c. All right, and this has to be equal to 0. All right, so c it happens to be just 0. All right, so therefore, Maclaurin series for natural log of 1 plus x is going to be equal to summation n goes from 0 to infinity and a negative 1 to the n x to the n plus 1 over n plus 1. All right. If you like to have just n instead of n plus 1, we can shift a little bit. This is exactly the same thing. So instead of starting from 0, we can start from 1. All right, so that we're going to put the negative 1 to the n minus 1 or n plus 1. It's going to give you the same thing. And then you have x is going to raise it to the n over n, right? You can shift the index a little bit to get a little bit simpler expression, but it's exactly the same thing. And another thing to note is that since the power series here only converges when absolute value of x is less than 1. So we have to make sure that we have the same condition here. So this makes sense if absolute value of x is strictly less than 1. Alright, that's it. I hope that this was clear.